Hi, in this recitation section, we are going to see how to prove that two sets are equal using subset argument. And before we get into that, I'm going to go again do some a brief review of some key concepts that we need to know in order to write a formal proof. So if you have a two set A and B, if you have two set A and B, A union B is a set of X such that X is in A or X is in B. A intersection B is a set of X such that X is in A and X is in B. A minus B is a set of X such that X is in A and X is not in B. This is the same as A intersection B complement. And the symmetry difference A B equal to A minus B union B minus A. And also A complement is the same as A, something like that. So these are very important concepts we are going to use here to prove. So, and you have to be familiar of what mean the or mean, the and mean. And because when you use the or, it means it can be in A or in B, and the and it have to be in both sets. So those are key concepts that you have to know in order to formally write a proof here. So let's take a look. And also this is very important because when you have such kind of expression, you can just transform it to get something that is look like this. This is more easier to manipulate. Okay, so let me pick one particular example that we are going to use here to illustrate our proof. So we have the set A. Let me just use this. We have A intersection B union C equal to A intersection B union B intersection C. So this is one of the distributive law, and we are going to try to prove this using subset argument. So first I must show that this is what we have to do. So you must show that A intersection B union C is a subset of A intersection B union B intersection C. Then you also have to show that A intersection B union B intersection C is a subset of A intersection B union C. So if you can prove these two expressions, then you are done with the proof. So let us see how to prove expression 1. So for expression 1, we want to show that A intersection B union C is a subset of A intersection B union A intersection C. So that's what we need to show. So to show this, we said let X in A intersection B union C. So I'm just showing you how you are going to formally write something like this. So if you have X in A intersection B union C, this implies, because we have the intersection right here, so this implies X in A and X in B union C, B or C. Let me just put B union C. So that's what we have. So we have X in A. X is in A. This is already settled because of this. X is in A, but we are not sure whether X is in and also x also is in B union C, but we are not sure whether this is in B or in C because we have the union here. So we have x in A. Now if I say if x is in B, because we have x in B union C, but we are not sure if it's in B or in C. If x is in B, this imply what? This imply x is in A intersection B, because we said that x is in A, right? So and if x is in A intersection B, this imply that x is in A intersection B union A intersection C, and we are done for this part. Now if you say that if x is in C, this implies again that x is in A intersection C, and this is because x is already in A, and if you assume that if x is in C, therefore x is going to be in the intersection because x is in both sets. Then from here we can conclude that this implies that x is in A intersection B union A intersection C. And you can tell that from we discuss all the cases, for the case where x is in B and for the case where x is in C, because we are doing this because we are not sure. If this was the AND, it should be very straightforward because we can know that x is in B and x also had to be in C. So but because it's the OR, we have to make sure that we discuss all the cases there. So this conclude that we pick the x, we pick our x in this set, and we were able to show, we pick our x in this set, we were able to show that x is also in this set, and also we did the same here. So we started off this way, and we were able to conclude that, to show that x is in this set, in A intersection B union A intersection C. So this part is done. Now we need to show that the other part, we need to show that for the second part, we must show that A intersection B union A intersection C is a subset of A intersection B union C. So we need to show this. Again, let x in A intersection B union A intersection C. This implies x in A intersection B or x in A intersection C. So this is by definition of a union. And from here we have, if x in A intersection B, because we have the union, this implies x in A and x in B, right? So we have x in A and x in B. So with this x in A and x in B, this implies x in B union C, because if x is in B, it's clear that x is going to be in B union any set, right? So we write this, I wrote this, we have x in B. So from x in B, I can say that x is in B union C, because it's the union, x can be in B union any set. So this could be any set, it doesn't matter. So we have x in B union C, and because we have x in A and x in B union C, this implies x in A intersection B union C. So this is the definition of a intersection of a set, right? Because we have x is in A and x is in B union C, therefore we can say that x in the intersection. So this again conclude the proof here, because we went from x to B in this set to x in A intersection B union C. So, but you have to be very careful. I'm just going to go back again and give you a more understanding of that. Again, you go from the fact that x, so we started off here. We started off here. Because x is in A intersection B union C, we can say that x is in A because the and, so we can say that x is in A and x is in B union C. Now, the question is, when you have basically here, when you have x in B union C, so s could be in B or s could be in C, but we already settled that x is in A. So this is settled. We are already sure that x is in A, but we are not sure whether it's in B or C. So that's why we pick the case where if x is in B, this implies x is going to be in A intersection B, because you already know that x is in A. So if x is in A and also in B, this is therefore correct, true. So that's why we went from this expression to this. Now, if you have x in A intersection B, this can be with the union of any set. That will still be fine. We discussed this last time, how to find the union of this set. So from there you can understand why this is true, why this expression is true. Because if this is true, you can do the union of this of A intersection B with any set, is still going to be true. Now you pick the second case. If x is in C and x is already in A, again we can have x in A union C. This implies x in A intersection B union A intersection C. So we are done with this proof. So let us look at this other example, the second part. We pick x in this set. From that definition of the union, we can get x in this set or x in this set. Now, because this is the and, this is going to be x is in, if x is in A intersection B, this is clear that x is going to be in A and x is going to be in B. And because x is in A, s can be in A union any set, and also s can be in B union any set. So for this case, we get x in B union C. Because x is in B, s can be in B union any set. So that's why we wrote this. Basically, that's why this is true, because x is in B, then s can be in B union any set, basically. So from there we got x in B union C. And if x is in A and x is in B union C, it's clear that x is in A intersection B union C. That's why we got here. And for this particular case, we pick x in A and x in B, then we got x in B union C, and we conclude our proof from there. So, and what the last thing that you have to do is to say that basically just say that if A, I call the first one A, if, so the last thing to say is just to say that since A is A intersection, so since A intersection B union C is a subset of A intersection B union B intersection C and A intersection B union B intersection C is a subset of A intersection B union C, then you conclude that our expression is true. So basically we are done with the proof here. And what you can do is you can always stop the video and try to understand better how the process works. So before we move to the next one, I'm going to go discuss something about your homework. So in your homework, you are asked to show that B minus A union C minus A equal to B union C A. And what I'm going to bring your attention here is you make sure this is not the subtraction of set. This is totally different. It's not like you are subtracting number or whatever. That's not what we are asking you to do here. And what you have to understand is that you can always, if you are not comfortable working with this expression, you can always transform this to something like B intersection A complement union C intersection A complement. It's the same expression equal to B union C intersection A complement. So if you feel more comfortable working with this second expression, feel free to do so. So you can transform this one to the second expression and just work with the second expression. So that's what I was trying to bring your attention here. And for those who are going to have a question about the power set of a set, the power set of a set A, we ask you to show that if the power set of set A is subset of the power set of set B, this is equivalent to A is a subset of B. So look at this equivalencies. It means that if this is true, this implies this, and if this is true, this implies this. So basically, you need to show that first. You need to show that if I call this expression 1, if I call this 1, and I call this 2, you must show that 1 imply 2, and you also must show that 2 imply 1. So that's what you need to show in order to prove this. And always remember, the power set of a set is a set of all subset of a set, including that same set. And if you pick, if I say that X is in the power set of a set A, that means what? Because we know that X is that means X must be is a subset of a set A or a set A, something like that. So that means X, this implies X is A of A, or X is A. I'm not going to go more into detail of whatever here, so but you understand the concept. I discussed what is the power set last time, so you can go from there and try to manipulate and see what you get. So I said again, if X is in the power set of a set A, that means X is a subset of A, or X is A, something like that. So you understand what I mean by that. So, and if you say that if you assume that the power set of a set A is a subset of the power set of set B, that means for all X in the power set of A, X is also in the power set of B. That's what it means. And you are going to use that this is just some hints for your homework. Again, so this is what I have for how to show that two sets are equal using subset argument. So thank you, and see you on the next video.